or two. Okay, so I wanted to show off a couple more kind of like cool features, cool things that Python has. These are just like none of these things are actually necessary for the language, but they are just like nice little features that do handy little things that are kind of yeah, kind of quick and kind of useful. After I think, I don't know, you could spend all day talking about Pythonic features, but I'll probably it'll probably just be this lecture, and then probably our next lecture will be we'll start looking at like SQL or something like that. Okay, so we have been looking at like object-oriented programming, looking at defining classes and stuff like that. And we created this class called a point, and inside class point we had an X value and a Y value, and we said and we defined two methods, right? The initialize method, which set the attribute X and the attribute Y, and then we had kind of a not a print method, or like the string method, which kind of gave the string representation of the object here. Okay, there is here is something not quite right. Should I I'll stop my share and then I'll try resharing, see if that fixes your issue. Share screen, maybe, I hope. Okay. Okay, so there is something called a named tuple, all right? And a named tuple allows you to kind of define a class definition if the class really just contains values and there's like no separate methods. So if you don't, like when we were defining the deck class, we wanted to have a kind of a bunch of methods that allowed us to do kind of comparisons and things like that. But in this case, for something like the point class object, we just need it to store an X attribute and a Y attribute. And so if you have a very simple kind of simple needs for a class, you can just use what's called a named tuple. Okay, so for this, I'm going to go ahead and just write an import named tuple. So there's kind of a package or a module in package or module called collections, and there's actually quite a few cool things in this collections module, but here we'll just import the named tuple. And then to create a named tuple, we're going to say, okay, let's define a point class object, or I guess a point, point class, and it's going to be a named tuple. The name is point, and it just contains two values. We give it kind of a list of the names that that we need to store here, which will just be X and Y. Okay, and so here, if we say, okay, what is point? It's going to say, all right, you've got this point class defined here. And then, and if you want to create an instance of the point class, you do it kind of just like you would create the objects earlier, right? So, so if you back here when we defined the initialize method, we say, take in the arguments X and Y, and assign it to attributes X and Y. And basically, we're going to do the same thing here, and but we're going to just say point. The coordinates will be 1 and 2, and then now when you ask for what is this, you get this is how a named tuple prints out, and it says, okay, this is a point, X is 1, Y equals 2. Okay, so basically, it's just a very, very quick and easy way to define a very simple class that behaves much like this kind of class that using traditional method of defining a class, but you can just do named tuples, right? You can just write this and just say, hey, I only need to kind of store values, okay? So, think of like a tuple where it's just kind of like you've got values stored in there, and that's what we have here, okay? And then so if you want to kind of ask, okay, what is the X attribute? It's 1. What's the Y attribute? It's 2, okay? And you can also just kind of say, all right, what is the value in the 0 index position? What's the value in the 1 index position? And then if you try to say, hey, what's the value in the 2 index position? It says that that's not there, right? So this is, so you can kind of get at all of the things, as far as the, within the tuple, you have a 0 and a 1 index and stuff like that, right? It is a tuple, so it's going to inherit all of kind of the tuple, the methods associated with tuples. So here we're going to have, point P1, P2, and P3, and we have points 0, 1, 3, 4, and 2, 2. And so if you wanted to compare P1 and P2, you basically just have a tuple and you're going to compare 0 versus 3. And in this case, 0 is less than 3, so that's going to come back false immediately, okay? And you could do that, what about P2 and P3, okay? So here the 3 is greater than the 2, all right? And here I could say, all right, what about 3, 4, and 3, 2? That's going to be true. I don't know. So you can kind of do tuple comparisons. What happens when you do tuple addition? Tuple addition kind of just joins them together, right? So here I've got P1 is the tuple 0, 1, and P2 is the tuple 3, 4. And here, you lose the named attribute, the named tuple kind of properties, right? So P1 is X is 0 and Y is 1. And here, when you kind of combine the two, it just creates this new kind of thing here. Okay. Here I'm going to create a list of the points. Okay. So I have P1, P2, and P3, and so now I have a list of these things, and we could say, all right, sort these things, and it's going to sort them, kind of using tuple comparison, right? So with tuple comparison, we have that. Okay, and then and if you do want to add additional methods, okay, you can inherit from a named tuple. And so I can say class UberPoint, all right? And so here we're defining a new class called UberPoint, which inherits from named tuple point. And then you can add additional methods, right? So we could say, I don't know. So if I don't like the way the named tuple prints out is completely reasonable to me. But, if I don't like that, I can say, all right, what, let's put in a method here, okay? Did I do this now? Okay, so okay, so we have that. Okay, and so now when I call print on this, it invokes the string method, right? So this is the representation, and this is what we have. I guess if I did. So this is not how you should do it, right? Okay, so the representation, this is not what you want. This is not how the representation method should be used, but if you did, then it would do that. Okay, so UberPoint, and it inherits all of that. Okay, so So I'll just say you can, the named people, pretty handy. And then if you do need to expand on it, you can create a new class that inherits from it. Okay, there is another another object or object type in the collections, and it's called a counter. Okay, and so this is just like a convenient way if you need to like tally up elements in a list or something like that. Okay, so oh, before I forget, let me give you your first view quiz answer. Today's first view quiz answer is the letter A. A as an apple. A as an apple is your first view quiz answer. Okay, so what we're going to do is we're going to import the counter from collections. Okay, and so let's say you have a list, and I'm just kind of using the example straight from the documentation associated with counter, and I have this list: red, green, blue, blue, and you just want to kind of tally up how many of each of these things do you have. Okay, so in R there's a function called table, and it does basically the same thing here. Here with word list, I'm sorry, in Python we have the counter, and you just call counter on basically all the elements. So I'm going to say counter on word list. I'm going to store that as tally, and here I get now a dictionary, and basically it went through and it says, okay, red appeared twice, blue appeared 3 times, and green appeared once. And that's that. So this is kind of a very convenient thing. I think, let me see. Counter collection. Can you pass multiple arguments? Oh man, I'm trying to remember. Okay, so we have collections. Let me go to counter. Elements. A new counter from an iterable. I think you join, if you have like multiple things, I think you join them together into a single iterable. So an example of the counter, let's see. So here they have, yeah, you pass a single iterable. So if you have like different lists, you have to kind of join them together. So if you have different lists, you can just use the plus to combine them into one list, right? So you wouldn't use you wouldn't do list 1 comma list 2, but you can just do list 1 plus list 2, and that will just kind of join them together into one long list. So it's a single iterable, and then counter will work on that. So here's an example where they took the text from Hamlet, and they ran a regular expression to just kind of split it all up into a whole bunch of words, basically a huge iterable of words, and then they ran counter on that, and it says, the most common words there are the and, to, of, I, you, a, my, and then Hamlet. So not exactly very revealing. This is probably going to be similar for a lot of English works, although perhaps I don't know. You'd think there's like is would show up here, but I don't know. Okay. Okay, so anyway, we have that, and then one of the methods for a counter object is you can call most common, and it will go through the values and pick the values with the highest value. So here I say I want the 2 most common things in the counter. Question: is the counter any faster than like writing the counting for loop plus dictionary setup by hand? I don't know if it's any. I haven't done any kind of timing things. It's just meant to be convenient. Okay. So these are just kind of like, little things in your back pocket that you can just use for convenience. If you're like, oh, you know what, I'm going to just set up a dictionary and just increment by 1. I'm going to iterate over, this list and do that. You can totally do that. there's nothing wrong with that. It's just because that's like a fairly common task that people do. Python has just kind of this convenience thing, right? Because I think, if you just remember, so that's the hardest thing with any kind of language learning, is that you just have to remember the vocabulary, right? And so it's like, oh, if you can't remember the word like washing machine, you'd have to describe it as like, oh, the box where you put dirty clothes in. And that's fine. People will know what you're talking about. And if you want to tally up the values, you can write your own dictionary, and it's totally a dictionary in loop and totally will work 100%. It's just counter is just a very simple common operation. So that's all, right? Same thing with the named tuple. This is completely unnecessary. You don't need a named tuple. We could just define classes the old-fashioned way. But sometimes the idea of a class that doesn't need any methods, just needs to store some attributes, is common enough that we have the named tuple there. Okay, we have list comprehensions. List comprehensions are basically like if you wanted to do a for loop and store your results in a list, you could do that. And a list comprehension is just kind of like a shorthand way of running a for loop. So for example, if you wanted to say you have some kind of iterable, here I wrote collection, but for some value in the collection, you can say, if this applies, do some kind of operation to the value and append it to your results, and you'll kind of grow your list that way. And sometimes you just like you don't feel like writing the for and a colon or something, and you can just set up a list comprehension. So like if you just wanted to create all the squared values for 1 through 10, you can do that. And it's the same as doing for x in range 1 through 11. First set up an empty list and then append each value to the list. And here you can just kind of take your operation and say, you know what, I want you to store x squared, and then you just kind of wrap it with square brackets to say it's a list, and then and it creates a list. This is called a list comprehension, and again, it's just kind of like a convenient little shorthand for saying, hey, I want to run through a for loop, and I want the results of that for loop stored in a list. And you can just say, hey, you know what, let's set up the list first. Okay, you can put it inside a NumPy array as well, and that will work too. You can also give it a condition. So here I'm going to say if x mod 2 is equal to 1. So we're doing the same thing. Do x squared for x in range 1 through 11, and it feels maybe the first couple of times you write this, it feels a little bit strange, like there's no line breaks or anything. You were just saying, okay, do this, for all of these elements, but only if a condition applies. So here we're going to say x mod 2 equals 1. That's odd numbers. And then so we'll get, all of the odd squares, 1, 9, 25, 49, 81. Okay, so here you can iterate not just over, you can iterate basically only over any kind of iterable. So we have, I've got the words a, as, bat, car, dove, Python. And what we're going to do is we're going to store the words as uppercase, x dot upper. And we're going to say for x in this kind of iterable of strings, and we're going to do it only if the length is greater than 2. So basically 3 characters or more. So we'll drop the a and the as, and it's all in uppercase. So we get bat, car, dove, and Python. I guess maybe animals, like the animals of the alphabet, elephant, frog, giraffe, EFGH. What's an H animal? I don't know. Hermit crab? I don't know. Hippo. That's much better. Okay. Jaguar. Okay. All right. Well, anyway. And then so somebody asked, like, hey, why does it print vertically? And this is just like what Python does. If you get too many, you have too many, if your results are too long, I don't know the exact threshold, but at some point, if your list gets too wide, it's going to make it vertical. So here I got I don't know how many characters wide this is, but at a certain point, it doesn't like having a really wide output. So then it just starts printing it vertically. And you're not doing anything wrong. It's just, that's just what it does. Okay, here is, so sometimes you want to pull out digits from a string. And so, a string itself is iterable. And when you iterate over a string, basically each X is a character, right? So we're going to say, go through each character here. And we're going to say for each character in the string, if that character is a digit, then make it a digit, okay? And so this is a string method, character or string.isDigit, and there's a few other string methods. IsDigit, and let's see, built-in types. So here's isDigit. Other things, you have isAlpha, which is going to be like, is it a letter? Is numeric. So alphabet, strings are alphabetic and things like that. Is decimal characters is digit. So, I don't remember what the difference is between some of these things. Is digit is okay. Well, anyway, this is what you have here. Okay. So is digit, and you can do that. All right. And here, we will also iterate. You can also iterate over a dictionary, right? So you can take a view object for a dictionary. So I can do dictionary.items. And so here, we'll establish our dictionary. We can do dictionary.items. And dictionary.items itself is a list of tuples. Okay, so I've got these things here. And then what we're going to do is we're going to create kind of just a list comprehension where we're going to kind of just unpack each of these things. So we're going to do for key value in the items here. And we're going to just say if the key is not B or D, and then we're going to say S is for blank. So we're going to just say like A is for apple and C is for carrots and E is for eggs. So I guess this is alphabet foods. F is for, I don't know, flour. No, who eats flour? Okay. That's what we have. Okay, same thing, same kind of idea. We can do a dictionary comprehension. So the same idea as a list comprehension, except you're going to have two expressions. You have an expression for the key, an expression for the value. An expression for the key can be, just as simple as, say, I mean, either of these expressions can be as simple or as complicated as you want. Okay, so here I have some iterable, that is, I've got this list of fruits: apple, mango, banana, cherry. And what we will do is for the key, I'm going to take the fruit and make it, I'm going to capitalize the first letter. And then the value that I'm going to store will be the number of characters, the length of that string there. Okay. And we're going to do it for every element in this list here. And there you go. Okay, and that's about as simple of a dictionary as you can get, but that's fine, right? Here it says create a dictionary where the key is the index and the value is the string. Okay, so this is what we want to do. So here is a bunch of strings. So we can do we can enumerate it, right? So enumerate's kind of just like a little shortcut for zipping together, you know, a range of the same length, and we're going to just kind of associate each element in this list with a corresponding number. So we got 0 and a and 1 and as and stuff, and we got, you know, basically this list of tuples here. So here I wrapped the enumerate and list. You don't need to do that. You can just give it enumerate strings, and the dictionary comprehension will iterate over all of these things. So this is wrapping something around in a list is like convenient if you need it, like if you want to see it yourself. But you know, as far as from a programming standpoint, it's more memory efficient. Not that it makes a huge difference with 5 elements here, but you know, if you have like a huge thing, you can do enumerate, and it's going to be kind of lazy, and it's only going to give you the things as requested. The dictionary comprehension, you know, kind of demands everything. So here we're going to take the index and the value, and here, as far as the dictionary goes, we're going to yeah, we're going to make a dictionary out of this, right? So we're basically going to take this. So I'm just turning the dictionary, the enumerate thing, into a dictionary, which is fine. I think we could do that. I think I might just do dictionary on enumerate strings. So what I did here is like so. So if you just did dictionary enumerate strings, you would have gotten the same result. Okay, that's because I just did index and value. But you know, again, the with the dictionary comprehension, you could make your key expression as complicated as needed to be, right? So here, if I wanted to for whatever reason, square the index or do something like that, we could do that, right? 0, 1, 4, 9, 16, 25. Whereas if you just needed to, if you wanted this kind of dictionary, just as simple, you can just wrap it up in dictionary. There's no need to do a dictionary comprehension here. But again, with the dictionary comprehension, you can make this as complicated as you want, right? So upper, or I don't know, whatever else you want to do with a string. Okay. Hello space, what's this? Okay. Hello A, hello bat, hello car, hello dove. This is stupid. Okay. So you have that. If I wanted to, I could flip this around. So here, you know, I could do dictionary enumerate strings, and I get, you know, 0 goes to A and 1 goes to as, and things like that, go based on kind of the position of the words in the list. If I flip this around, okay, then I could say A is position 0, as is position 1, bat is position 2, so on and so forth. With the index map, if I say, hey, what is oh, well, first of all, I messed this up. Okay, but with the index map that I've done here, okay, there's no key for A. So I can do, you know, index map, you know, 3, and it will say, okay, the value associated with the index 3 is car, but I don't have anything associated with A or car or something like that. Whereas as far as the location mapping, I can say, all right, what is the location of A? Location of A is 0, location of car is 3. Okay, so that's what we have. if we wanted to join the two dictionaries together, we can combine dictionaries like this. Probably the best is to do to use update, but here's like I'm creating a new dictionary entirely, and I can just unpack, scatter the first dictionary, scatter the second dictionary, wrap those results in the dictionary itself, and that's what we get here. Okay, but here we're gonna I'm gonna just say take the location mapping, which is this, and we're going to update it with also the index mapping, and both of those things will get put together. So we'll have A goes to 0, and we'll also have 0 goes to A, and as goes to 1, and 1 goes to as, and we can do that as well. And so this is, so I'm not sure. I don't know why this one prints out vertically and this one prints out horizontally. This is, I don't know. I don't know why. So this is strange to me, but there you go. That's what happened here. So I'm going to look that up. Why does Python print vertically? No, is it? So if I do print location mapping, is that going to print local mapping? Oh, look at that. So what's the limit on print? What if I did no, I can't do that. I don't know how to double the length of a list. So I have that. Oh, rep and string might have some different limits or something. That's a good point. Okay, good point there. Okay, generator expressions. Okay, so we have something called a generator expression, which a lot of times looks and behaves very similar to a list expression, except they're lazy. Okay, so generator expressions are only going to give you the value when you ask for it. Okay, so here I can do G is equal to, and so you create a generator expression almost the exact same way that you would create a list comprehension. Okay, you do a list comprehension kind of like this, and for generator expression, so here I have this, and here I'm going to just, the only difference is instead of a square bracket, I'm going to use parentheses here. And so here, here I said, what is G? G is a generator object. Okay, and then you get, okay, what's the first value here? We're going to ask next G. So range 12, it starts off at 0. Okay, and what's the next thing? It's going to be 1. What's the next? It's going to be 4. What's the next? It's going to be 9. And then we're going to just say, for each thing in G, kind of just print all of these things out, and it goes 16 up through, say 121. Okay, and once it reaches the end, if you call next, it's going to say it's run out. Okay, it's a stop iteration. Okay, so it there's no more, there's nothing left here. So okay, so what's the difference here, right? So here I've got a list comprehension. L is a list, and G is a generator expression. Okay, and here if I say what is the type on L, that's a list. The type on G is a generator. Okay, and if I ask, what is L? Oops. Okay, there's a whole bunch of stuff here, right? L is a little bit too much, right? There's 1,000 of these things, whereas G over here just says it's a generator object. So it hasn't actually done any of this stuff. If we ask, so one thing is that the generator just takes up less space in memory. So one thing you can do is you can ask, what is the size of this object in memory? And it's not like this is a huge amount. So, who really cares, for something like range 1,000. But I guess it could make a difference for like range 1,000,000 or 1,000,000,000 or something like that. Okay. And basically, the list comprehension requires that all of the elements in the list get calculated, and it stores the entire list, right? So all 1,000s, I guess we just did n times 2. So, all the values from 1 through 1,000 multiplied by 2, those were all computed and they're all stored in the list. Whereas as far as the generator, it's just instructions. It just says take the next number and multiply it by 2, and it does that. Okay. Now, so one thing is that the list, you can say, hey, what's the index 4 thing in there, and because it's computed all of them out, it's going to be able to tell you right away and say, yeah, the 4 times 2 is 8. Okay. Whereas the generator, it only computes the next value when you ask for it. And actually, as soon as it calculates it, it forgets it. Okay. It just says, here's the number, do with it what you want. And then I don't care after that. Okay. And it doesn't remember anything. So with the generator, you can't actually, kind of subscript or anything like that. Okay. So, again, if you just kind of need something to kind of run through something, you can just say, sum all the objects in the generator, and it will do that. And you can ask sum all the objects on the list, and it will do that, and you'll get the same value. But, this is technically, a lot kind of more memory efficient, right? So if you just need to kind of do something with the values, and you don't actually need to like store the individual values themselves, perhaps a generator is good enough. In a lot of cases, probably in your day-to-day, it's fine to just use a list comprehension for everything. Just because I think as humans, it's easier for us to kind of work and interact with lists, and we kind of like that the thing exists and doesn't disappear as soon as we get the value. So a list comprehension is kind of nice and convenient, but yeah, if you're trying to eke out a little bit more performance or something, a generator expression might be the trick. Okay. Let me just give you your last 2 view quiz answers, and then we'll look at the map and lambda functions with the last few minutes of today's lecture. So we have, second view quiz answer is the letter B, and the third view quiz answer is the letter C. So B as in bear and C as in cat. B as in bear for number 2, C as in cat for number 3. Okay, I'm gonna use a little bit of regular expressions. So I have to import the regular expressions module, which is RE, and regular expressions. They are great, but we don't have time to cover everything. But basically, one of the things is you can say, hey, anything that's a space character, okay, space character and one or more of them. Let's just replace it with a single space. That's what this thing is. So substitute one or more space characters with one space character is basically what I'm saying here. Okay. And writing a function called replace underscore space. And so it's going to take some string X, it's going to search for anything where you have more than one space, and it's going to replace it with a single space. So here I have hello, Alabama. And then there's a bunch of spaces between hello and Alabama, and there's a space after Alabama. And what it's going to do is when there's multiple spaces in a row, it's just going to replace it with a single space. Okay. And here's a single space is replaced with a single space. Okay. I've got a list with, I don't know, just different text in here. Okay. And we might want to say, let's go through the the list, for each element in the list, I want you to run this this function replace space. Okay. And really, it's only going to make a difference right here for South Carolina, where we have 2 spaces, hello, space, 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 Alabama. Okay. It's not going to make a difference here. There's only 1, and there's no spaces in any of these things. So really, we're just going to be looking at South Carolina and hello, Alabama. Okay. And then so when we do map, we say map the function onto the text. This is going to give us a generator expression. Okay, yeah, that's kind of one reason why I wanted to cover generator expressions. So when you call map, you basically get, well, this map thing, and it's going to behave like a generator expression. So so what I'm going to do is I'm going to just call this G2, and then we'll call next, and it runs through each of these things. So we get hello, Alabama. We call next on Georgia, and we can go over and over and over. And so we can say for item in this. So here I'm creating a new generator expression, map replace text, and we can go through and print all of these things. And indeed, it has fixed this. Yeah, so map is similar to the apply function in R, very similar. And it's just, you take your function and it's going to run it for each kind of element. But it does it in a, the Pythonic way, in that, you get like this generator expression and you have to call next on it for each of these things. Now, if you want and you say, stop, I hate having to deal with the generator expression, what you can do is you can just take the thing and you can wrap it in a list. And then when the list function runs, it's going to say, okay, I need all the elements. I want you to calculate all of these things now, so I could put them in a list, because in the list, I don't want to have to generate anything. I just want everything right now. I'm going to store it. So you can just take the generator expression, wrap it in a list, and you will get all of your results. Okay. I mean, we could have done that back here as well. Like if I did G and I just said list on G, okay, like this would have forced it to compute everything out. Okay. So, that's kind of silly. The point of probably writing a generator expression is so that you can kind of save yourself some memory. But yeah, with map, it's always going to create a generator expression, and you can kind of call next to get the next values as you want, or you can just wrap it in a list and it will calculate everything else. Okay. Now, a lambda function, okay. A lambda function is, let's say you have kind of this operation that you need to do, but it's like so trivial that you feel like it's a waste to have to define an actual function. Like here, I defined a function called replace space, where I'm going to go through and I'm going to go take the argument X, and I'm going to replace, multiple spaces with a single space. And you might say, you know what, it's silly to, excuse me, one moment here. Okay, so here, you might have felt like, oh, it's so dumb that I have to define this function just for this simple operation. And so you can create basically what's called a lambda function. Okay, and a lambda function is like a function that you didn't bother naming. All right, so you give it the name of the argument, and so we're going to say, hey, take the argument X. Right, so this is basically like, here's a function, and the argument that we're going to put into the function is X, and what I want you to return is this. So with the lambda function, it's basically a simple thing where you're just going to return a simple expression. And so I mean, you can make your lambda functions more complicated. The purpose is, like, if you just need to do a simple thing and it's going to return a simple value, and in our case, we just want to return the string after we replaced, one or more spaces with a single space. Okay, so here we're going to do lambda X on this, and we're going to do run the list there, and there you go. And so here we didn't have to like call replace space. Here's kind of a similar thing where we're going to just take an input string as an argument, and then we're going to turn it to title case. Title case is first letter is capitalized, after a space, the next letter is capitalized. And so here's just, we just want it to return a simple thing, put the string in title case. And so in this case, we don't want to have to go through the trouble of defining an actual function, right? We're just going to say, hey, do a lambda, and we put it inside map, okay, because this is the function that we want to kind of map to our list of text, right? Here's our list of text, and we want to kind of map that function to the text, and we can do this, right? So here we're going to take our text, which so the only thing that really wasn't title case was this lowercase Georgia, this lowercase South Carolina, and we can see that we applied it here, and now it comes back in title case. If you want to make a more complicated lambda function, you can. And so here is a lambda function that takes in two arguments, x and y. And so we have that. And so we're going to do map. So our function takes in an x and a y, and it's going to return x plus y. So it's silly. And so and what we will do is in this case, because the lambda function takes in two arguments, we have to provide it with two iterables to iterate over it. And then it will go through each element and do this. So this will do 1 plus 100 and 2 plus 200 and so on and so forth. So we're going to have to provide kind of two lists or two iterables for it to iterate over. So here we've mapped lambda x and y there. Okay, so that is lambda functions. And again, generally for a lambda function, you want to keep it like a super simple function. Just otherwise, if you make your lambda functions too complicated, it becomes hard to read your code, right? But sometimes your function is simple enough that to define a full function where you're just returning one value feels like it's a little silly to actually have to define that. And if you're not planning on reusing something like this, a lambda function can do it. Okay, that's it. That's it for today's lecture. So we'll go ahead and wrap it up there. And I appreciate your flexibility in meeting online tonight, or today. And so have a great rest of your day, and we will see you on Friday.